Okay, so infrastructure as code. I'm curious about this because I heard Pulumi just did an announcement recently, and for Java developers in particular, is that what you're going to talk about?
Yeah, so Pulumi just released support for the Java language to be able to do infrastructure as code, where you deploy resources on your favorite cloud providers like Azure. And I was one of the devs on the team, so I had some capacity to put together this presentation and share it with you guys.
Yeah. Awesome. I
gotta say, we're lucky to have Kyle because he is, knee deep in the code itself and helping to actually deliver it. So it's great to have him here because he pretty much knows everything about the release and everything too.
All right, sounds good. So for people watching, if you have questions, send those questions over your chat on YouTube or the Learn TV platform. If you're watching through Learn TV, that's where we are following most of the conversation. So, all right, thank you, Brian, and thank you, Kyle. And you can start your presentation now. We'll see you later.
Cool.
Sounds good.
All right. So I guess we should share. Yes, we should share that slide. I'll start off. If you don't mind, I'll just say hi. Welcome, everybody. My name is Brian Benz. I'm a cloud advocate at Microsoft. And Kyle, please introduce yourself.
Yeah, so like I mentioned, I'm Kyle. I'm a software engineer at Pulumi. I worked on the Pulumi Java project. So if you look through the code base, it's open source. You'll see a lot of commits you'll see a good number of commits with my name on it. So yeah, that's basically that. Just hop forward through some slides. All right, so got us. My GitHub's over here. It's github.com/Dixler. You'll see Brian Benz. It's github.com/bbenz. And so today we're going to basically be deploying a Spring Boot application to Kubernetes on Azure using Pulumi. And since we've just released Java support for Pulumi, we're going to be doing it in Java. So I'm going to be talking a little bit about what infrastructure as code is. And then Brian's going to be talking a bit about what Kubernetes on Azure is. So on the right, you'll see the application we're going to be deploying. It's a Spring Boot application. Like I mentioned, it's got this cute little developer advocate, and we're going to be toggling the picture on and off using feature flags on an app that without having to deploy it. So like you can read here, Pulumi is an open source infrastructure as code, a library /framework /tool. So you can see it on GitHub and actually make pull requests or issues in order to, I guess, see the code or contribute. So we support a lot of, well, basically all the major clouds like Azure, AWS, Google Cloud, as well as like platforms like Kubernetes. So we have packages at the link over there, but we've been working to build a lot of relationships with a lot of businesses in the cloud ecosystem to create content and participate in each other's events like this one, provide CI/CD integrations, and also make providers so that people that use Pulumi can be able to use the clouds of the people we're partnered with. So you can see over here, so infrastructure as code. Pulumi is an infrastructure as code tool. If you guys haven't heard of what it is, it's a way to use code to deploy and manage resources on your favorite clouds like Azure, AWS, Google Cloud, or platforms like Kubernetes that we'll be deploying to today. And you'll notice that there's an asterisk next to code. Infrastructure as code comes out of the configuration management space, which means a lot of the languages that we use are configuration languages like YAML. And an example of one is here. This is called Helm. It was released in 2015, a year after Kubernetes was released. It's basically a templating language and packaging system layered on top of Kubernetes deployments. And it's a little verbose and a little hard to write, but it's easy to consume. But you'll notice that if you're trying to author stuff like this, there's a lot of if statements and a lot of domain specific stuff. Like you have to know Kubernetes as well as this templating thing. And for a lot of people, that's a pretty large, bit of a barrier to entry. So this is the first 50 lines of a 200-line file. So I'll skip that part and skip straight to a timeline. So here's a lot of the tools in this space. They all use a very similar model. There's this declarative kind of style of configuration management where you just declare all the resources that you want to use on a cloud, and then the engine or the tool will read that file and then put all those resources there or edit them to put them into the configuration you want. So YAML's really dominated this space as an authoring language because it's very easy to write. But as a lot of the clouds got much more complex, a lot of the cloud native applications got more complex too. So So a lot of these languages kind of layered a lot of things like pointers and references, API calls, and for loops on top of this YAML syntax in order to be able to meet those needs. And you've essentially reinvented programming languages, but in their own unique way. So learning these new frameworks is a pretty large time investment, and without the support of mature tooling, you're essentially defining this cloud, like your entire production environment using something like notepad.txt. So Pulumi kind of takes a different approach with that. So you kind of get to bring your own language. So in this case, we're going to be talking about Java. So you get a lot of features like static typing, you get first-class functions, you get a lot of the object-oriented features like you can do inheritance, what's the other one? Interfaces, stuff like that. So you get your expertise around building abstractions around that. And you also get the features your IDE supports, like IntelliSense, code completion, linting, and Java docs. So you can basically read a lot of the documentation that you'd have to flip between your browser and your editor with just straight from your IDE. You also get to use your favorite tools like SonarQube or JUnit, and build tools like Maven and Gradle. And you get to leverage the existing package ecosystem that for publishing and for consuming. So, and on top of that, you get to use the declarative model that the configuration management systems really really tested over the years. So you get to preview the changes you're going to do before you actually do them. And like I mentioned, we've added support for Java, so now you can use the Java ecosystem in order to write your infrastructure as code. So with that, I'll kick it over to Brian, and he'll tell us a little about Kubernetes and Azure that we'll be using today.
Thanks. Yeah, so basically, I'm going to talk about the target environment that we're actually running this on, and then Kyle's going to give us a demo of how we actually get there with Pulumi from a GitHub repo. So first of all, there's a multitude of target environments you can use for your Java applications. This one happens to be a Spring Boot app, and it runs on app service. It runs on our container services. It runs on Kubernetes, of course, because you can containerize it and put it in there. We also have vendor arrangements with Red Hat for Red Hat OpenShift, Oracle, IBM, JBoss for multiple platforms, including our PaaS service. And we also integrate with all the tools that you're familiar with, IntelliJ, Eclipse, et cetera, et cetera. And we can move to the next slide, and I'll show a little bit about the AKS service, if you don't mind. Thanks. So, when you're setting up a Kubernetes service, generally you're going to have some kind of workload definition in Helm or something similar to what Kyle talked about. And then you're going to have a Kubernetes API endpoint. And then you're going to have all this stuff in that box there that you have to manage yourself for orchestration of a Kubernetes cluster on VMs. So what we do, if you just hit enter there, Kyle is going to show what we do is we actually just add a management plane that you can use to manage your Kubernetes cluster automatically. So it sets up everything you need for orchestration. All you have to do is bring your code and run it. And you can choose the underlying infrastructure of VMs that you use to run that, which is that little bit of eye chart along the bottom there, which is the VMs that you're using to actually borrow nodes and pods from your VM clusters. So there's no charge for the management plane, and everything works from there. Okay, so let's, I guess I should show my screen to show the demo here. I'll show it real quick. So what we did is we actually took an app.jar. For those of you who watched my session earlier today in the North America time zone, it's the same demo, but instead of building it and deploying it with a GitHub action, this time we just took the app.jar that was generated from that, and we containerized it and deployed it. So it was nice and quick and easy. We have a separate build process, and we're just focusing on the deployment here. This is Bit. This is our developer advocate mascot at Microsoft, and basically he's a feature. If I go into my feature manager in Azure, this is a feature manager. It's just like this. You just literally turn it off. It says it updated the feature flag, and when I refresh it, there you go. Bit's gone. And then I can put Bit back by enabling that beta feature. So that's basically feature flags in a nutshell, and they're enabled by this thing called application configuration. And that's what the config store is up here. You create a new service and you get a connection string, and you use that connection string to connect the app to the feature manager. And that's basically all there is to it. I like to use this demo because it shows you connecting to something. Usually, a Hello World demo is just not a great one to me because it's not what you implement in a real world situation. You need to connect to something. So I connect to the feature manager here. It could be a database, could be whatever, but generally you need connection strings or something on the back end when you're building an application, at least a couple tiers. And then it's actually deployed into a Kubernetes cluster. So the Kubernetes cluster that I show you here, if I go over to the right here, you can see there's a couple of external IP addresses connected to load balancers. We also have some cluster IPs internally for management. But this is all automatically managed by Azure for you. You literally just create this using Pulumi in this case. And Pulumi actually then deploys the application and sets up the connection string for you. And Kyle's going to explain how that works in a sec. But that in a nutshell is how that works. Everything here is organized into a resource group. That's what this square is with resources. And we've got a few different clusters here because we were playing around with things to test stuff out. This is the original one that I sent over to Kyle. And there's a few clusters we built since then. But it's kind of cool that we can just build clusters and try stuff out. And then when we're done with this, we'll just delete the whole resource group and everything will be gone. So it's a nice way to be able to contain and manage all your resources and everything there. But yeah, okay. So that's basically what I wanted to show you. The repo, Kyle shared the repo he's got, but the code for this is actually at, if you go to aka.ms/devops for Java Shell, you'll find the details. And I'll kick it over to Kyle to show how we actually got to here, and I'll bring Bit back.
All right, so thanks, Brian. So I'm actually going to be splitting this up into like two projects. So Pulumi, you could deploy this entire thing with like a single Pulumi program, but that's not exactly that interesting because I know there's a lot of places where you have one team that manages the platform and another team that manages the app development. So there's got a platforms team and then a Java team. So I'm going to split it up. So the first stack that I'm going to show off is going to be the platform stack. It's going to be the Kubernetes cluster, the configuration store, as well as the namespace that it's going to deploy to. But I'm sure all of you are really interested in seeing this thing actually get deployed. So I'm just going to run Pulumi. I'm going to run Pulumi up, which basically runs your Pulumi program, figures out the resources that it needs to deploy or wants to manage, and then deploys them. But we've already deployed it, so it's not going to show any changes. So I'm going to run yes. I'm going to click yes, and it's going to show me the outputs for this cluster. So this cluster is so the app stack, the app dev stack is going to be using a lot of these using these resources in the deployment. So it needs to be able to know what the values are for them. So in a little bit, it's going to output the values that are attached to these resources. It can be a little finicky sometimes because you have to connect to the cloud and query it for a bunch of stuff. So here we get the kube config, the configuration store connection string, and the namespace, and we kind of need those in order to authenticate with Azure as well as the Kubernetes cluster that we deployed. So we're going to have an application over here. I'm going to deploy it from scratch. I deleted it earlier while I was testing this out, and I'm going to run Pulumi up on the stack, and then it's going to run this program, figure out all the resources that we want to deploy in here, and then it's going to ask me if I want to deploy them. Well, it's going to show me a plan and then ask me if I like the plan, and then I'm going to say yes because, well, I want to deploy this thing. And then it's going to run the deployment. And this can take a little bit of time because it has to download a bunch of resources on the cloud. So while it's doing that, I'm going to kind of look at the code. So first, we have the platform stack. As you can see, this is a build.gradle. We support integration with Gradle and Maven. And for more details on how we do it, we've got the docs over here. And in order to use Pulumi, you need the Pulumi SDK. It's over here. It's pretty straightforward with that. And these are providers. So these are the libraries that are going to let you be able to construct resources on your favorite clouds. For example, we're using Azure over here and Kubernetes over here. So these are auto-generated from the schemas that our cloud providers give us. So we got this schema from Kubernetes. So recently we got a schema from Kubernetes when they were deploying, and we were able to build and deploy an SDK automatically before they finished releasing their new version. So we had support for it before it was even out, which is pretty cool. So we keep up to date. And then we'll be over here. So this is the Pulumi program. It looks like every other Java program. You got your main function, and then you've got this Pulumi.run method. This actually runs this function inside of this inside of the Pulumi engine. And so this is going to deploy an Azure configuration store, an Azure Kubernetes service cluster, and then a namespace to the cluster we're deploying in the same place. And by now, this thing should have deployed. It outputs a URL, so we can easily click it. And I'm going to go over here, and you can see we've got bit. And if I go over to the feature store, I just have to find configuration store. Just need my browser to load it.
I don't know if anyone, this is pretty remarkable what just happened. I mean, we just created several services, including Kubernetes, which used to take like a weekend, and and set it up, and we're running on a cluster, and you got the app running. It's pretty amazing to me. And
yeah, it's
all in Java.
Yeah, and then you can click disable this, and then if you refresh it, after a little bit of refreshing, it should be gone. So which is pretty neat, and then you can turn it back on and off however you feel like it dynamically without having to redeploy anything. So pretty snappy. Well, sometimes it takes time for the thing to requery it. So
I'll just while you're doing that, I'll just mention as well, you can also do things like have a certain percentage of people see the new feature versus the old feature, and you could time box when you actually display this feature, and also do things by region, a few other things. So check out the app config. It does more than just manual turning it off on and off. It's kind of cool.
Yeah, it's pretty neat. So over here, we've got the function that's going to be deploying all these resources. So we do this we follow an object-oriented model, which means that we just construct resources using constructors. So it's very idiomatic and very friendly to like pretty much every Java dev that's used Java. And we'll need to name it. So the first argument is always going to be a name. So we need to track this because we're going to be running this multiple times, and it needs a way to like correlate this configuration with this name. And then we use builders, which make it really easy to configure this resource that you're doing. So if you just do .sku, it'll, one, you get your Java doc here, you get your completion, and when you type something that's improper, Java will complain at you to fix that. And then we have these custom resource options over here. There's more details on all of the custom resource options we support, but these will come into play a little bit later. So over here, this is the Kubernetes cluster. You basically configure it. It's straightforward using the same builder stuff. Like you can IntelliSense your way through all of this stuff, and wherever else that fails, you can check the docs. But you'd be doing that anyway if you interact with cloud so. Over here, we've got these configuration options, and here we put the protect flag on here so we don't accidentally delete it, because these things take like 6 minutes to 13 minutes to deploy, and that would basically eat up all my time. So in order to deploy a namespace to that cluster, we're gonna need to get these ops over here. So these are resource options, and you saw them up there earlier. We need to tell it how to connect to Kubernetes. So we got this thing called a kubeconfig. It's basically like an authorization token or an API key. And we can grab it from the cluster over here and feed it in here. It's kind of like a client for an SDK, if you're familiar with that. So if you go in here, we have these functions that are really helpful. You can learn more about them in the documentation. Basically, there's a bunch of static methods you can call to query Azure for information. For example, we want to get the credentials for the cluster that that's over here. And then we basically, we take this thing, and we notice while I was developing it, I saw that this is like a base64 encoded Kubernetes thing. So I was like, oh, I'll need a base64 decoder to do that. So, having the docs right there saves you a lot of time, like switching back and forth and like doing the whole debug loop where you type some code, it crashes, you fix the crash, and then it crashes again. So that's how you create the namespace. And later on, we're going to need to use this configuration store. So we've got that connection string that Brian alluded to before. We use these functions over here on this service to grab that. And then we save them as secret, and we save it as secret so that so that we don't like throw it on the screen.
Yeah.
So We then output these from the stack in order for the other stack to be able to use them to deploy to this Kubernetes cluster. So that's basically it for this cluster. And then we have this other one over here that just that was able to use all of this. So this one uses Maven. You'll see a pom.xml over here. So like I said, we support both of them. And you'll see the main function here, Pulumi run. And this is and the way that this is gonna work is this is gonna upload a jar file to Azure and then create a deployment on Kubernetes that's going to download that jar from the internet and then run it. So that's kind of straightforward. Pulumi has its own way of doing configuration, setting configuration values. And then we've got this stack reference thing. This lets you be able to grab the values from this other stack. So you can kind of communicate between two stacks using this. And this uses the Pulumi service that we have, but we have other backends that you can look up on the docs. So got the kube config here. This is going to serve as our authorization, as our API key, basically. And then the namespace we're going to be deploying to, and then the configuration store. The configuration store's connection string, which is also like an API key. So all this code over here is basically just required to upload a jar file to Azure. If you're not familiar with it, it's basically a way, it's kind of like, it's just cloud, it's basically cloud storage. And then we pass it a path to a file, and then it's able to upload that. And then we've got
because it's federated, right? It's linked in with the rest of the application. So that's the idea. Is your blob storage is part of, it's accessible to your Kubernetes cluster.
Yeah. So we've got we also have to create the feature flag in order to use it. So we're going to use a connection string in order to create a to create a client for the configuration store so that we can create the flag in there. So this is actually using the Azure SDK. This is Microsoft's SDK, not Pulumi's. And one thing to note when creating resources on Azure using their SDK is that Pulumi isn't aware that they exist. So if you destroy the stack, make sure that you're keeping track of it. It's kind of like manual memory management versus using a garbage collector that's aware of everything that exists. So definitely be careful when creating resources on clouds without, without infrastructure as code. So here we have this custom component. It takes a name in order to manage it, and then we have this app args over here. It's going to pass all these parameters that we need in order to construct this deployment on Kubernetes. And then it has the same provider thing that we saw earlier, where this is used to connect and deploy stuff to Kubernetes. And you'll notice in here that you can use Lombok in order to create builders and getters without having to write any code. So if you're into that sort of thing, you can do that. So if you go to this is a custom resource that I put together. This is the deployment. It's down here. You can use references. It's pretty nice because then you can break them out and then you can test each of these individually and make sure they're sane. You can also put parameter checking in here to make sure that all the stuff you put in here is valid, because while Pulumi and Java, while Java has like type checking, the strings that you put into these things may not conform to like a DNS name. So you might want to put in tests yourself to make sure that these things are correct. And you don't usually get that with a lot of infrastructure as code tools until like you run it and then it crashes. So so then you get the service, which is going to expose this to the internet. They expose this deployment to the internet, and that's about it for this deployment. So
cool.
Yeah.
Beautiful. Yeah, I was going to mention a couple of things. So you mentioned the resources that just might get left hanging. As long as you group them in resource groups, like I showed earlier, it's a handy way to be able to see what you've got. Like our mess you see there in our resource group. There's a few leftover things there. And yeah, of course, this you showed IntelliJ here, but it works with Eclipse as well, which is cool. So, everything that you've showed here, I believe as well. But yeah. That's great stuff. And you mentioned the Maven, you're using Maven for the actual portions of this. You can actually use Maven for the build as well. We just chose to use the app.jar because we knew the app wasn't going to be updated often. But you could actually implement the same Maven build that we have in the original demo into this as well. So yeah, it's kind of cool.
Yep. Thanks. Yeah.
All right.
And that's all I have. So Appreciate being able to share this with you guys. Definitely check it out and tell us what you think, because we are in preview. So, if you have ideas on where we could go or ways to make it better, definitely let us know.
And there is a separate conference going on right now, right? Pulumi Up, which is happening today or tomorrow?
It was today as well as tomorrow. So we've got like 2 days worth of stuff.
All right. So for more information, check that out. Just search Pulumi Up. I assume it'll be out there somewhere. But yeah, we'll bring back Bruno. And thanks, Kyle. That was great.
Thank you.
All right, folks. Thank you so much. This is awesome. I got to say, I love the Kubernetes YAML to Pulumi tool that you have. Brian knows how much I love that tool and why I do. Good to see this.
Big YAML fan. Yeah.
No, this is good stuff because I mean, most developers have IDEs already that know these languages, these first-class languages, right? And sometimes, I mean, CLI is great, but you have to do shell scripts to use CLI tools from cloud providers. So having like a DSL, so you can check in on Git, you can check libraries and dependencies, integrate with stuff. You can even build products and software that will use this code to manage a cloud infrastructure in a nice way. So I think this for software makers and end users is such an amazing technology. So thanks, Pulumi, for doing that.